Hello and welcome to the Tech Lunch podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listener's ears to new and exciting technologies they may have not been privy to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
And I'm John.
Hello, I'm Ed.
And this week we're going to talk about how we're going to kind of actually tie into last week's episode with the 3D printing stuff. We're going to kind of go on how 3D printing can help STEM education. And, with that, it's more or less like, what can you learn from it and how you can use that, and possibly in the classroom, or even if, you want to learn, STEM education at home and you have, something that you need to go with. We talk about, using G code, stuff like that, which is, just a modified math language, but, I'll leave it open to y'all. Whoever wants to respond first, we'll go with it. How do you think that, the 3D printing stuff can actually influence STEM education at any level?
Honestly, at every level, curiosity drives a lot of learning, right? So why does that work? Why is it doing this? I remember in one of my first physics classes, like taking away oxygen and on a candle and the light going out, the fire going out. That phenomena is amazing. So if we are able to kind of use any of those, physics ideals, mechanics ideals, or anything like that, and relate those into problem solving, like puzzle solving, like, okay, well, I need these pieces to go into this to this box a certain way, or to fit this puzzle, but on a smaller scale, like building a Lego robot or something like that, or 3D printing a robot, actually, would probably be a lot easier than getting a Lego robot to stay working for you. And then you can continue on from there into, now I need to, I'm going to put these posters up. So not too far. And then once you get into the higher level geometries and pre-calculus, calculus, you can say, all right, here's an egg. I need you to 3D print some type of enclosure where I drop this off the side, no parachute or anything like that. Which one can survive the highest fall? Yeah. And not just grading them on performance based, but like contribution. Everybody's participating, so it's competition breeds,
ingenuity.
Excellence, and ingenuity. But it's something that you can scale too, because like, right? What if I asked you 3D print your car?
Yeah.
I mean, you couldn't do it right now, but Ed probably would try to be doing it tomorrow.
Yeah. So. And if you think about it, with that, not to, really jump in, but, Ed, you need, wanted to voice your opinion. But, you start thinking about all the phenomena. You're talking about taking, especially in 3D printing, you're taking a liquid going to a solid. Yeah. And it really depends on which one you go with. If you go with, FDM, you're melting that plastic down to a liquid state and drawing with it to a hardened state. But now if you go to the resin printers, you're using, now you get like chemistry. You're dealing with how light takes a resin-based system and turns it into a solid, no matter how you look at it. So you're kind of dealing with, not just chemistry. You're also with the physics side of the house. You start thinking about the different phenomenons and how that kind of plays into place. But, I know you're getting ready to, say something, Ed. What are you thinking?
Well, I'll say the thing that I think that's great about 3D printing or the technology is that it's now become affordable.
Yeah, exactly.
Anybody that wanted to maybe print an exploded view of something so you could see how the inner workings of something works, it's inexpensive now compared to subtractive manufacturing, where you have to mill these things out because this takes specialized skills to do these things. With 3D printing, there is some specialized skills you have to have, but the thing about it is you get to use CAD models and you get to use all of the things you learned in physics and mathematics, and you get to learn by making, like actually putting your hand on it. It's like a person that makes a vase or a person that makes something out of clay uses their hands. Mm-hmm. They don't just snap their fingers and make these things. So it's the same thing in a way with 3D printing.
Yeah.
And what I do believe that would make STEM more attractive to kids is if you were able to explain to a child, hey, this is why you're doing this. Hey, this is why you use this type of cylinder, and you use this type of lever, and you use this type of fuel ratio, and then you make a spark, and then you get combustion, and it pushes the piston down. Mm-hmm. You can show that, So I think that's a really good way to use 3D printing.
If you think about it, also on top of that, you have the guys who are building the rocket nozzles, that can screw on to liter bottles. So when they did the liter bottle rockets, using using methane and using butane and water. It will take that and convert that to into a nozzle like what they would use on like the Saturn V or something like that. And actually, you can actually see it when they do that. Will actually produce mock diamonds. Mock diamonds is if you're thinking about it, how you can, and they do print 3D rocket engines or nozzles for like SpaceX, Blue Origin, and all of them. They still do that. They also do all the reciprocating pumps and stuff like that as well. But if you think about it, the mock diamond it's a phenomenon based on the speed of sound coming out the bottom of an engine. So instead of a solid plume, it looks like a stacked set of diamonds on top of each other. That's why they're called mock diamonds. When they're coming out of the bottom of an engine, that's actually based on how efficient, how tighter the diamonds are together means the motor is actually more efficient. So you can actually 3D print those nozzles to have a liter bottle do it for you. And you can also hook those up to a little mini rocket engine and actually print those to actually test the mock diamond phenomenon.
Okay, and it'd be structurally sound, I bet, to make it like you could scale. Like we talk about it quite a bit as simplicity scale. So if that's like working on that scale, who's to say you can't size that up and use that to get to space? I also wanted to think there was something else that Ed kind of was speaking on as well as when we were talking about STEM activities or scaling with 3D printing as you grade school, middle school, high school, you're going up the ladder there. Hell, it could even get used in medical school. Like we can 3D print those pieces that you really can't work with too much on a huge scale with mass manufacturing. You can make those little pieces that maybe I need to stitch this back up. Maybe I need to check to find if there's some internal bleeding anywhere, and they can set that up there in such a way that you can practice on that. So it goes all the way up into your masterate, your doctorate, all the way, all stages of education. So I just it's something to think about because it can be implemented so many places in just the pure prototyping. Just the pure prototyping is vital, and I don't know. That's interesting to me. If I can make it, I mean, I'd fly paper planes when I was little. If I could 3D print a plane, I'd be doing those instead.
Yeah.
Yeah, one thing that Nick said that really caught my attention was robotics, and robotics in the sense of being an assistance robotic, where we have a collaboration between a human and a robot, like right there together, and they're doing a low torque robot that even if the robot was able to get inside of the collision zone with a human, it could never hurt that human, but it could make that human more productive. Mm-hmm. I think that if you could take things like that and give it to kids when they're young and let their imaginations run, and then you say like when we had the Mars Rover, say like, think about we had one type of design for Mars Rover. What if a kid could get that and say, hey, we can make the Mars Rover not only have to have this type of energy to keep perpetuating itself.
Now, kind of when you're thinking about, the Mars Rover type of thing, going on that thought process, You know, if you think about it, you can 3D print 95% of the components. That's on a 3D on those things. But you know, with that, because you know, you can actually do metal 3D printing now at some levels. You know, we got rockets that are being 3D printed at this moment. But if you think about it from a STEM education standpoint, does 3D printing fall under, which it still will, I'll fall under either or, STEM or STEAM? Because now that we've, rolled, the arts into, the STEAM methodology or the STEM methodology and turned it into STEAM, over the past, couple years, that's kind of where that falls in. Because if you think about it, some of these guys, they might not be interested in the math behind it or the science behind it, but you got some of the people out there who are really big into like computer aided design, CAD, or any of that stuff. You're one step away from getting to a 3D printer. Mm-hmm. You can go out there and get one of the what we call the lazy man printers, where it does everything for you right off the rip, and then you don't have to touch it. It's it'll do it on your own. If you don't understand CAD modeling, you can print it yourself.
Yeah. And it's funny that you mentioned like relating it to STEM and the CAD and all that. There's really two sides of the coin with 3D printing. So like depending on how you learn or how anyone in STEM learns, it's to me it was hands-on. So I'm doing this. I need the physical part here. I need to do the process to find out what's wrong, what's right, what works, what doesn't feel right, and how to move forward with any issues and troubleshoot. Now that feels like it's more the physical side of everything and the hands-on thought process. There's very much so the other side of the coin where it's everybody's theoretical. They're just in their head thinking about, oh well, this is beautiful because of how this this symmetry looks, or I could make this look better with a bit of symmetry here, and I can make this more sleek here, and push the mold on the actual model instead of having the physical piece and thinking about, hey, I need to print a wrench because I don't have this specific size right now, and I need to get it done right now. It's hey, I want to print this wrench because I want to size it up and put it on my wall to make it a bit of wall art, just because I like mechanics or I like just how this looks. And it kind of touches both sides of the thought process and the learning process there for a lot of the STEM, and that's how it gets into the arts. There it goes from mechanics into art. Like it doesn't have to be functional, but still you're making something sizable.
And that's it's curious that you and Nick both bring that up, because there is a tie-in from the artistic to the actual industrial side of that. Ergonomics. Mm-hmm. Yeah. We develop things like things that we use to brush our teeth or brush our hair. We develop the way laptops look or tablets look or how they fit in your hand. Mm-hmm. We develop steering wheels. We develop how the dash fits around a person as opposed to being some obtrusive object. Right. So that's a good point. But I like to go just a slightly one different way. I would like to look at it from, what if it's another type of art? It's a dying art, but it's an art nonetheless. It's the people that still create watches from scratch. Yeah. Okay. What better way to teach a person that's passionate about mechanics and art, and having them design a watch, and they can 3D print the parts and look at it and see how it works, and maybe they come up with a different way for a watch to work, or maybe the look of the watch is different, because everybody has smart watches, and it's nothing wrong with that. That's really neat, but it's always like human.
The old mechanical watches.
They have something mechanical to me. What do you think?
No, I love mechanical watches. I'll tell you right now. I've been to a couple countries and walked through a couple watch shops and a couple clock shops and stuff like that, and seeing the old school, old fashioned, mechanical way of doing things is It's an art. And like you said, it's a dying art form because some of the guys don't want to be doing this anymore. You don't want to have the guys making the old-fashioned cuckoo clocks anymore. You don't want to have the guys, maintaining the old-fashioned, hand crank watches. Yeah, grandfather clocks, exactly. I still have a mechanical watch, and I love the damn thing. Don't wear it a lot because of work, related issues. But, other than that, it's still one that I keep, around the collection when I can. But, and it's one of those things of where if you start looking at it from like the 3D printing standpoint, every little bit helps. And, that's the big thing, like what we like to try getting at is, and why we've hit on a lot of STEM related, topics in the past couple weeks. It's, trying to drive that point home. There's a need for it. There's an absolute desire for it at this point in time. And, that's kind of what we're getting at. And with that, it's kind of like, where can we go next? What is the next logical step when it comes down to using 3D printing in the classroom? We got to look at it from, the math teacher standpoint, the technology teacher standpoint, the science teacher standpoint, and the engineering teacher, if they have one, some schools do, standpoint. The engineering teacher, we know where that goes. You got, the engineering teacher and the art teacher get together and you got CAD. Yep. That's how that goes. You get the art teacher and the math teacher get together, you have G-code. And, vice versa. But what is the next logical step that y'all are thinking about going forward if you're talking about using a 3D printer in each classroom?
I'm thinking about, of course, we always kind of touch on prototyping and things like that. But I'm thinking we need to figure out a way that's more of how do I find a solution to this problem? Like, okay, I've got this leak here, or I've got this pipe that needs to supply pressure evenly amongst these three here. And it may, for me, that's in a textbook on paper, and I'm doing a whole bunch of calculations and drawings on the paper. But going into like grade school, I didn't know any of that stuff. So having it actually in front of me, being able to print those pipes and fill them up with water and see what it actually does, as opposed to trying to theoretically prove the mathematics behind it, is leaps and bounds. You're going to get into this so much quicker, so that when it gets to that point, you're going to say, oh, this is how it behaves. And then now the teacher, the math teacher, the calculus teacher in college is going to say, okay, yeah, that's absolutely how a rate of change works, and that's absolutely which one would fill up first. How did you come to this conclusion? And they can physically show their work, for lack of a better term, your work. So getting to those people who they say all the time, I'm bad at math. Okay, well, here's the model. Go try it. Go test it out. Get your hands dirty and see what it does. So you can learn that way, and getting them at a young age. I mean, the kids are playing in the sand anyways.
Yeah.
So why not get them to play with something that's going to teach them something that they'll work with later on?
I'm a hands-on math type of person, so I have to know what I'm building to be able to do it. That's the only way I can learn upper level math, is if I'm building something and I have to use it with it. And I still do it by hand just so I make sure that I'm right.
Yeah. What's crazy? He said sand. So to me, the next level is microscopic and macroscopic. I'm able to take a semiconductor and show you this on a molecular level, but I 3D print it where you can see it in your hands and say, oh, that's what that looked like, and this is what it looks like when I put a certain current a certain way, whether I forward bias or reverse bias, and this is what happens. And this is this region. This is the region in between the two that separates the two. Yeah. This is the layer that opens and closes. It's a switch. Wow. Okay, now I understand what you mean by it's a switch. And if I'm looking at a macroscopic level, I look at a piece of rock or quartz, and I see all the crystals in it, and I'm able to print out these crystals. Then the kid can see, hey, okay, I understand what you mean when you're talking about how these things are compressed together, and over time you get these things. Even if we look at it from the point of view where, hey, I take a carburetor, 3D print this carburetor, make it in different sections, and show the person how the carburetor works. Show the person how a heart works. I 3D print it and show them, hey, these are valves.
Yeah.
These valves work in a certain way. If one doesn't work, you can show it malfunctioning. This is what will happen, and you can see this in real time. Then, as you said, I can visualize the mathematics. I can feel the mathematics with my hands. I can manipulate mathematics with my hands.
Now, if you think about it, if you take a lot of times we're talking about FDM printers. That's kind of what we're getting at. However, if you take the resin printer, go back into that little topic real quick. You throw that into a science class. You've now proved that light can change, or it can change a liquid to a solid easily. And you now have physical, viable proof, of different, laws that you're dealing with. Different chemical laws that you're dealing with at that point. You're dealing with crystallization at that point of a liquid to a solid. You're not waiting for something to go bad because you let the lid off of it. You're actually making something physical with that to prove a point that, science in the real world does exist. Now, I know we're getting, towards the end of time here. But, however, this is kind of where, Ed, I'm gonna jump to you real quick, and kind of, targeted your direction. Do you, you being a dad and you being, a grandpa, do you think that if there was a chance to put 3D printers in every single classroom, could that change the trajectory of the lives of some of those kids being in those classrooms?
Yeah, 100%. And the reason I believe this is because I went through traditional schooling as well as public schooling.
Yeah.
We went through public schooling.
Yeah, so
and there's some limitations between with public schooling, and there's some limitations with some of these phenomenons. It's hard to wrap your head around these phenomenons if you can't relate it to something. So if I can visually, physically, mathematically, all in one swoop with a 3D printer, of course it would. Why wouldn't it?
Do you think that would get people more interested in STEM and get people going into STEM careers?
I think that would make people change STEM from what it is and turn STEM into something that it was supposed to be.
Yeah, I can agree with that.
Yeah. I mean, I 100% agree with that because when we're talking here, we're talking the big picture, like including 3D printing in all these classrooms, improving the life of those and the trajectory of their learning or their future learning. But for me, it's like this. It's like a spark, like a passion was found. So the first 3D printer that I came in contact with and was working with was in college. It wasn't till then, and it was just this little resin printer, this itty bitty guy. I didn't even remember the model, to be honest with you. But it stopped me, and I was curious to see what this little thing that's buzzing in the corner is doing, and it's printing like spindles or gears for other projects that some of the seniors were doing. So seeing that just sparks something. You're like, why are we doing this? You really can make that? Oh, well, I have this other project that I got stuck on because I don't have the specific machined part or something like that, and you could just make it in house. And if it's something as simple as like a building block or something, if you get down into the pre-K and the younger realms, then why wouldn't you make that on site? It's more sustainable. You're not like you're printing as needed, so you're not overdoing. You're not going over your budget or anything like that. And it's so much cheaper than buying anything in mass quantities for like a whole district or something like that. So you're trying to spark a passion. And showing this kid this little machine that's making something from nothing, creating something, and you tell that kid that he could be anything he wants. I feel like those things just immediately relate, and now that person is like, okay, well, maybe I can print me a spacesuit or something like that. Maybe I can go to space, and then it just grows the curiosity from there. And that's all we're trying to do is you just grow spark that curiosity and just see where it goes from there.
Yep. And with that, I'll say this. I got a lot of friends who are teachers, in different aspects of the educational universe. But anything that we can do, from a person standpoint, a company standpoint, to a technology standpoint, or anything in between, to help drive STEM. Drive people into STEM education and drive people into STEM careers and stuff like that, is looking out for the bottom line. And what that bottom line is the future of the world at this point. We have to have people in all those career fields. And, if we can find one way of doing that to influence that change, we'll definitely do it. And, that kind of, leads me to this, if you have the ability to make a change, implement one of these 3D printers in your classrooms or something like that, do it, play with it, have fun with it. That's kind of we do like to leave people, with a charge at the end of the day. So, I'm going to leave that for our last little, outro piece here to Ed, and he'll leave you with the charge of the week.
So for me, you can give a person material, or you can give a person a 3D machine and he can make the material. So with that, what I would say is, as always, we appreciate everybody that supports us, and anybody that's just joining, we appreciate it. And we really would like everybody to try to learn something different each and every day, even if it's only for 5 minutes.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.